Hi everyone and welcome to today's Physics Daily Booster. This is number 9 in our Paper 1 series and it is an advanced information listed topic for both foundation and higher students. So relevant for all today. What we're going to start off with then is having a look at the idea of gravitational fields. Now hopefully we know that a gravitational field is just a region where a mass experiences some form of attractive force. I.e. when you're in that gravitational field, you're being pulled towards the object that's basically causing it. Now, what we do have is this idea of a gravitational field strength or gravity constant, sometimes referred to as G. And this is the measure of the force on a 1 kilogram mass when it's in a gravitational field. So, key thing here, we need to make sure we're not mixing up two words. Mass is literally the measure in kilograms of how much stuff something is made of, whereas we can also refer to the force of weight, which would be measured in newtons. So just please be careful with those two terms because we often use them as interchangeable and they're not. Because when we're looking at obviously the effect of gravity on an object, the mass is not going to change. The weight, which is affected by the gravitational field strength, will change. So when we put this together, what we have then is that the force that acts on the object in that gravitational field will be larger if one of two things is true, or both of them. First one, if it has a larger mass, we have a larger force. And secondly, if the distance between those two objects is smaller. It wouldn't be a physics booster without a calculation, of course, so here is the one for today. So gravity force is the mass times gravitational field strength. Now it is worth remembering that when we're talking about gravitational field strength here on Earth, that just has the value of 10. So 10 newtons per kilogram is the gravitational field strength on Earth. So if you had someone with a 60 kilogram mass, for example, 60 times 10, they have a gravity force of 600 newtons on Earth. What we're referring to there then is their weight, okay? So the weight is the force due to gravity that acts on an object. And if you look at our little formula there, weight is the mass times gravitational field strength, you've got the same formula top and bottom there. So mass times gravitational field strength, that gives you the weight or the gravity force that's acting on that object. The next calculation we need to know then is about our acceleration due to gravity, because that G can also refer to the acceleration due to gravity. Now, if we have a look, resultant force is the mass in kilograms times the acceleration due to gravity. What we're doing here is just mass must be kilograms, watch out for that being in grams, and then we just multiply it by the acceleration due to gravity. Now, if we are here on Earth, the value that we should use for this is 9.81. That's going to give you the most accurate answer. In a number of questions, they will allow 10, but I would always recommend using 9.81 to get your accurate answer here, especially considering some of these questions will then follow up with that 1 mark for the right number of significant figures because they'll be testing that bit of your maths knowledge. Next section is gravitational potential energy then. Hopefully we do know that when we lift an object within a gravitational field, we are transferring energy to the gravity store. So this is then referred to as the gravitational potential energy of that object. Two things that are going to determine our GPE, the mass and the height. So we can put that together into our nice little formula found on the formula sheet, of course. GPE, which is obviously energy, therefore measured in joules, is the mass in kilograms times the height in meters times gravitational field strength, which if we're on Earth is just 10. So things to look out for here are of course the units for the mass, the units for the height, to make sure that we have done any conversions required before we jump straight into the calculation. Don't forget that where we come to calculations, of course the thing to remember is show each step of your working, and I would always recommend checking your answer on a calculator. Even if you want to do it in your head first, double check on a calculator, because you might think you're amazing at mental maths, and some of you may well be, but in an exam situation, silly mistakes take place. Don't throw away your calculation marks by just being a bit blasé and not using the calculator that you are allowed in every science exam. final thing to do for today then is head on over, have a go at the quiz and see how well you've understood this. This is going to be the last quiz because looking at the number of you actually doing these quizzes, then it's not really worth it for a grand total of 3 people. So we will still carry on with the daily boosters, but there won't be a quiz at the end. So my recommendation is, once we've done these, is head on over, have a look at some of the past exam questions on the OCR website. Obviously go back over anything you're not 100% certain in using your notes, the videos on the channel, revision guides, etc. And obviously make sure that you are aware of those calculation style questions.